So we are continuing with our tiny field trip, and there was a mistake on the last video. The location there was 1 mile west of Lewisburg, not 100 miles. That was on Route 60. Anyway, this is I guess you'd say a geologist's hammer, and it's used to obtain samples of rock. So something many times you do on a field trip is you break off a piece of rock, and you keep that piece of rock, and that becomes part of your collection. Now, I didn't do any pieces of Greenbrier limestone at either one of the previous sites. One reason, because I have had about 18 tons of 3-inch samples delivered to my house to fix holes in my road about a month or so ago. So here is some of my samples. And some of these samples contain more of a mineral calcite to them. So officially, a rock is a mixture of different materials, and a mineral is a specific chemical formula. So right here, if we can see it, and we can't so much there, the light isn't very good, but some of these rocks will have little bands of calcite in them. So calcite chemical formula is CaCO3, whereas limestone in general has more other stuff mixed in with it. But I picked out a couple of pieces of calcite, and here they are. And you should hopefully be able to see this somewhat. And again, the light's not showing up too good on this. But there are bands that are whiter and have the surfaces of them that have facets to them that are reflecting light. When my kids were small, I had some limestone sand delivered from my local quarry, and so this was the place where I had it dumped, and my kids had played in the sand pile basically. So sand officially is the size of particles, is what determines that, rather than the chemical composition. Most of us, when we think of sand, think about silicon oxygen compounds, but this quarry sold limestone, primarily calcium carbonate, CaCO3, as sand broken into particles. Anyway, since my kids grew up, I moved the pile to there with my tractor. So there's my limestone sand pile, and I dig up samples of that to take into school for labs where we do reactions with calcium carbonate and usually vinegar. Something else that usually you would have on a field trip is some hydrochloric acid. And hydrochloric acid is used as a chemical test for calcium carbonate or limestone. So whenever you react hydrochloric acid with calcium carbonate, you get a gas produced, which is carbon dioxide. And I'll tell you a little bit more about that reaction a little bit later. Now, what I figured out over the years is, instead of using hydrochloric acid, if I use vinegar, which is also an acid but a weaker acid, and I use limestone sand, this came out of my sand pile, then I can get a reaction because there's more surface area to the particles. So here goes. This is vinegar being poured in my limestone sand. And we are getting some bubbling occurring. And the bubbles are carbon dioxide. So in class, when I do this in chemistry, and sometimes I'll do this in earth science, we take a wood splint and light it. And when you put the wood splint down in the bottle, it goes out because that's carbon dioxide. And the carbon dioxide displaces the oxygen that would be necessary to keep the burning going. It's kind of windy today, so I can't show you that. The smaller the particles of the limestone are, the faster the reaction goes. So the limestone sand reacts faster than my 3-inch particles would. This same quarry is starting to sell limestone. It's even finer than sand, and it's being used by farmers to put on their fields to raise the pH of their soil so grass will grow better. And the smaller the particles are, the faster the reaction goes. So it breaks down faster. And it's kind of like this. If you imagine, I happen to have a round bale of hay out here that I'm using to mulch my area where I got my tulips. So if you put out this is just part of a round bale of hay. But if you have one round bale of hay, there might be 15 sheep that can line up around here to eat on this. One round bale of hay is equal to about 10 square bales of hay. So if you were to put out 10 square bales of hay, then lots more than 15 sheep could surround them to be able to eat them. And each one of the square bales of hay is broken into flakes. So if you were to take those chunks of the square bales of hay and spread them out, even more sheep could eat on them. So the point here is where the reaction occurs is around the outside of one of these rocks. So the smaller the rock size, particle size are, the more area they have for that reaction to be able to take place.